Hello, I'm going to solve the tutor example 1. This example is a little bit math oriented. So let's see how it goes. So it says write a computer program where the user will enter two numbers, positive integers only, separated by a comma. Okay, determine which number is a factor of the other, else return -1. So the two numbers will come in separated by a comma. Now determine which number is a factor of the other. Okay, and now you bring the output. So example, the person entered 9,3. So we say 3 is a factor of 9. In case he or she entered 3,9, we will still say 3 is a factor of 9 because 9 can never be a factor of 3, but 3 can be a factor of 9. So we realize that smaller numbers can be factors of bigger numbers, but bigger numbers can be factors of smaller numbers. That is concept 1. This is a concept, it will not be in the question, but you should know as a user. Okay. And the last concept I want to deal with is it says that what 2, we need only positive integers only. Okay, positive integers only. Now if it's not a positive integer, the computer shouldn't accept the input. Okay, that's why the last point is here, validate the user's input, otherwise prompt them to make corrections. Okay, so we are going to take in two numbers separated by a comma. We're going to ensure that both two numbers are positive integers only, and if they aren't, we'll prompt the user for what? We'll prompt the user of his or her input. Okay, so let us go ahead and write some codes. So tutorial example 1, I wrote some codes yesterday, but let's start all over again. So our algorithms are straightforward. Step 1, take the inputs separated by a comma. Okay, step 2, find which one is the smallest. Then step 3, find the remainder. Then step 4, find the results. Okay, sometimes it may take you some time to develop the algorithm, but I've gone straight for it to develop it so that the video can be a little bit short for all of us. Okay, so let's continue from here. Now we are going to take in the input. So let's say nums, meaning both numbers, input, enter your two numbers. Automatically we know he or she is going to separate it by a comma. Okay, so now enter your two numbers. So the person inputs, let's say 9,3. Let's assume the person types it 9,3, and you know that for inputs it always comes as a string, so it's going to have this kind of data. So then how do we verify that the person has inputted two numbers? So what we have to do is we have to say maybe split num or nums is equal to this number, okay, or this string that we've taken, nums dot split. We use the split function because it's a string. Then we say split by what? The comma. Split by the string what? Comma, called comma. Okay, so from after it has been split by the string called comma, what we are going to get as the output is going to be something like this. We're going to get a list with 9 here, comma, with what? 3 on the other end. Okay, so we are going to get a list of 9 and 3 which has been splitted. Now as I said earlier, this 9 here is in position 0, and this 3 here is in position 1. Okay, so we can go ahead, and anytime we want the 9, we just say split nums position 0, then split nums position 3. We specify their positions using the square brackets. I'll show you how to do that. So from here, once we had this data, now we know that one criteria for you to be a factor of another number is to be smaller than that number, and and 2 aside the number itself. Okay, so here we are assuming that no number will be entered twice. So aside the number itself, you have to be smaller than the number you are a factor of. Then 2, you should be able to divide that number without a remainder. So your remainder should be 0. Okay, so 1 be small and 2 your remainder should be 0. So let us see for the first condition. So if the split nums, the number in position 0 is greater than split nums, the number in position 1. So if this 9 is greater than this 3, but remember, this 9 is still in a string format. Okay, so what I want to do is I want to convert it into what? A list, into an integer. So before I write my if statement, let me do my conversions. So I can say the num1, the first number, is equal to the um, split split num. So this list, then I specify position 0. Okay, then I say my second number is equal to the split but in position 1. Okay, so as I said, this is position 0 and this is position 1, not 1 and 2. Okay, so but then I need to convert them into what? Integers. I convert them into integers. Okay, so let's quickly convert them into integers. Okay, I'm done converting them into integers. But then we need to verify the results. So if the person enters a wrong data type, let's say the person didn't enter a number, we can just say try. Okay, so we'll deal with that one later. Sorry, let's deal with that one later. So let's focus on the main goal. So we have the split input, like the split nums 1 convert to an integer, then split nums 0 convert to an integer. Okay, so now that we have our numbers, we're going to say if the number 1 is greater than the number 2, and for this case it is true. If the number 1 is greater than the number 2, I'll just say pass. I'll come back to it later. Else, and automatically, if this number is not greater than this number, it means it's less. I've already said that there is no equal to here. The person cannot enter the same number twice. Okay, so else pass. So else, it means the opposite is true. So now let's assume that the first number is bigger than the second number. Okay, so the first number, and for our example here, it is true that the first number is bigger than the second number. So if that is true, then it means that we should rather use the second number to check if the second number is a factor of 9, because automatically the 9 can never be a factor of 3, but 3 has the potential of being a factor of 9, but we don't know yet. And to be a factor of a number, when they divide that number by the other number will yield a remainder of 0. Okay, so let me quickly demonstrate it here. So let's say you have 5. Okay, 5 mode. In math it's modulo arithmetic. Let me start with a comment. So we have 5 mode 2. 5 mode 2 simply means that when you divide 5 by 2, what is the remainder? So 5 divided by 2, the remainder is 1. Okay, when you divide 10 mode 3, the remainder is what? 1. You can say 20 mode 6, the remainder is 2, because 6 3 18. Now the remainder of 2. Okay, so once the remainder is 1 1 2 or any number, they are not factors. 2 is not a factor of 5, 3 is not a factor of 10, 6 is not a factor of what? 20. But then you can say let's say 40 mode 5. So 40 divided by 5, the remainder is 0. And you can see 40 is a factor of, 5 is a factor of 40. Okay, anytime a number is a factor of another number, and the number, when you do your modulo arithmetic, you're going to yield a 0. Okay, so modulo means that divide the number, but we are interested in only the remainder. Okay, we are not interested in the whole number. I know 5 will divide 40 8 times, right? 5 will divide 40 8 times, but what is the remainder? Is 0. 6 will divide 20 3 times, the remainder is 2. 3 will divide 10 3 times, the remainder is 1. 2 divide 5 2 times, the remainder is what? 1. We are only interested in the remainder. But in Python, we don't write mode, but rather we use the percent sign. Okay, we use the percent sign. Okay, so I should have added this to the arithmetic operations. So modulo arithmetic. So you can reference it later on. So if we want to find out if the smaller number is a factor of the bigger number, we have to put an if statement here. If, and we've confirmed that num1 is greater than what? Num2 here. So if the number 1% divided by the number 2, the num2, and the remainder is equal to 0, then it means it's a factor. So you print num2, comma, is a factor of num1. Okay, so if num1 is greater than num2, then we say num1 divided by num2. If the remainder is equal to 0, then it means num2 is a factor of num1. So we print num2 is a factor of what? Num1. And we move on. Else it is not a factor. Print. And they told us that if it's not a factor, we should print -1. I think I didn't read that part of the question. So if it's not a factor, we should print -1. Okay. Then now let's go to the else part. So with this else, it's saying if num1 is greater than num2. Okay. Else it means that num2 is rather greater than num1. So repeat the entire code here, but we say if num2, now we know that num2 is the biggest one. From this code, num1 is greater than num2, but then it failed. Leading to the else statement. Once this one fails, the computer jumps to the else statement, and this one will only fail if num2 is rather greater than num1. And since we know num2 is greater than num1, then we have to use num1 to divide num2 and see the remainder. Okay, num1. So num2 is the biggest in this case. Divided by num1. If the remainder is 0, then we say what? Print num1, comma, is a factor of num2. It's a factor of num2. Okay. Then in case it fails, in case it detects that it's not a factor, you can say else print -1. Okay. Else print -1. So I think I'm done with my code, and let's see. Let me run it as usual. So we are going to test it with n3 and 9, and our final answer should be, so when we say 9, 3, it says 3 is a factor of 9. Okay, it's working. But let's go through the codes again. So at this part, the computer takes in 9, 3. Now the computer splits it into 9 and 3, but they are still strings. But for num1, we say num1 is equal to what? 9 for our code. Okay. And after doing that, we say num2 is equal to 3. We convert both of them into integers given the data. The data could be anything. It could be A, B, it could be anything, but we are just using 9 and 3 as an example. Then here we are saying that if num1, oh wait, let me put a hashtag. If num1, and num1 is 9, so if 9 is greater than 3, then the computer should do this. The computer should rather also check for if 9 divided by 3, the remainder is equal to 0. It's checking for factors. Okay. Now, if it is true, it should what? Print 3 is a factor of 9. I'm just using the comments as what is happening throughout the code. Now, if it is not true, that means you are going to get an else statement. Else, none of them is a factor of the other. So we just print what? Print -1. Because if the smaller one can be a factor of the bigger one, there is no way the bigger one will be a factor of the smaller one. Okay. Now from here, we are saying that now, should in case the number we entered, okay, here, in reality, it was, let's say, we had another data such as 21. After splitting, we got 21, 81. Sorry, 27. That's the other example, 27, 81. Now, we got this data, 27, 81. You could see that the 27 before it is smaller than the 81. So in that case, excuse me. So in that case, if the number in the first position, which is 27, is greater than the number in the second position, which is 81, and it is false, the code will fail. And it jumps to the else condition. And the else condition follows the same format. Now, and remember, you don't need to put a condition for the else, because the else relies on this condition. You are saying that if this condition fails, automatically come and do this. Because if this condition fails, the opposite is true. For example, if it's not daytime, then it is night. There's no way you can be in between it. Okay. If it's not in the daytime, it is night. Okay. If the sun has not risen to the sky, else the sun is, or else we are in the night. You don't need a condition to say else the sun is on the other side or whatever it is. So automatically they work like hand in hand. So if the if statement fails, the else statement automatically takes over, and you don't need to write a condition for it. Okay, so this code works similarly to this one. So we are assuming that and this code will only run if the first number is smaller than the second number. Okay, so we are assuming that we've had another example where the first number is smaller than the second number. So we say if the second number 81, I'm just using that, divided by the first number 21 has a remainder of 0, sorry, then you print what 27 is a factor of 81. Okay, then let's see, else automatically none of them is a factor of each other. Once the other one proves not to be a factor, the bigger one cannot prove that it is a factor. So else print what? -1. Okay, so this part is dealing with a condition when the first number is smaller than the second number, And this part deals with a condition when the first number is rather bigger than the second number. Okay, but then the code told us to check for validity. So we want to check if the user has entered the right input. Now, if you say it should be converted to an integer, and the user enters something like apple, banana, the computer will fail. So what we do is we say try. We told the computer to try converting these two into integers, and if they fail, they should rather do this, except this, print you have entered the wrong data or values, whatever we want the user to see. You have entered the wrong values. Okay, so we tell the computer to try converting these into integers, and if it fails, tell the user that you've entered the wrong value. But then, after telling the user you've entered the wrong value, the computer will still go ahead to run the if statement. But then, since it failed here, these num1 and num2 wouldn't exist. Okay, so once it fails, this code down here are likely to fail. So you just put what? Exit, meaning it should end the entire loop. So once you run the code, okay, and this one fails, the computer fails to convert them into numbers, it should print you've entered the wrong values, then exit from the app, your application. Okay, so that with that being said, I guess I've carefully solved the problem. But then take note, solutions to problems do not come like the way I did it. For me, I wrote the codes out, and when I ran it for the first time, it works. But for your case, it's not going to work like that because this problem has been practiced. Okay, I've written the problem, actually developed the problem myself, and I went through it, and this is not the first time. So um, do not assume that you should be able to write code for the first time and it works. If you run it for the first time, expect it not to work. Always expect your first code not to work, your second code not to work, your third code not to work, your fourth code not to work. Always expect that something shouldn't work because there are always errors until you get experience and you begin to see that, oh, your codes are really working well. Okay, let me end the video here and let me tackle the tutorial problem 2. Bye.